Hi, good afternoon, everyone, and a very warm welcome to all of you. Thank you for joining us today for the University of Bath Masterclass from web search data to business insight, how business analytics support real industry decisions. This side, Ishanka Huja, I'm client engagement specialist at StudyIn, and I will be moderating today's session. At StudyIn, we support students in exploring global study opportunities and making informed academic and career choices. In today's digital world, organizations generate enormous amount of data every day. The ability to analyze this data and turn it into a meaningful insights has become one of the most valuable skill in the modern side of business. So this session will explore how business analytics transforms larger scale business into real business insights that support decision making across industries. It is especially relevant for students interested in business analytics, data science, technology, and data-driven decision-making project. It is now my pleasure to introduce our speaker for today, Dr. Meng Meng. She is the Senior Lecturer and Director of Studies for the Masters of Business Analytics program at the University of Bath School of Management. So before we begin, a quick note for everyone. The Q&A option is available at the bottom of your screen. Please feel free to submit your questions during the session and we will address them during the end of the session. So now without any further delay, I would like to hand over the session to Dr. Mung. Over to you. All the best.
Thank you so much, Ashak. Let me share my screen.
Yeah.
Can you see my slides here?
Yes.
The full screen of the slides? Double check.
Yes, it's visible.
Okay. Brilliant. Thank you so much. Thank you so much, everyone, for joining us. And thank you, StudyIn, to organize this special event. It's a great pleasure to present one of our case studies in our student summer project. So the title of this presentation is From Web Search Data to Business Insight. Before we start the real project, I want to give you an overview of our business analytics program. My name is Dr. Meng. I'm the director of study for this program over the 4 years already. So it's a great pleasure to have a brief overview of this program, and then we can link this to our project directly. And at the end of this presentation, we will have the Q&A sections as mentioned just earlier on. So I think some of you already know University of Bath. We are quite a well-ranked university across the world and as well as in the UK. I just put one of the QS ranking here, but apparently we rank much higher in the other rankings. In terms of the university ranking, we ranked about 132 globally, according to the recent ranking result. And our program, Business Analytics, ranked about the range is about 50 to 60 from the last result. And we are the top 10 in the university of the UK. Business analytics has the diverse career opportunities across the sectors. So in the past years, our students normally worked as the data scientists when they graduate from the program. So they can work in the healthcare sectors, they can work in the bank sectors and the consultant sector as well. So as long as they have the data, our students can produce their business insights out of the data. So it could be very diversified after they graduate. We are quite small class size in terms of the program settings. Normally, we have 30 to 40 students each year in one cohort. We have both lectures and seminars for each of the unit. The lecture covers about the theory part, the technical part, where in the seminar sections, we provide the hand-on experiences in programming and analytical tools. Each of the unit will covered by more than one programming coding skills. So later I will give you a brief overview of our structures. And then we use the real data site in the final dissertation in the summer. So that is the most of my frequent meetings these 2 weeks, because students will have their final exams in the coming next week, and then they will start their dissertations immediately after that. So we work on the real-time data, and they also have the opportunity to work with our industry collaborators. So the industry collaborator come up with the data and the questions, and our student will help them how to generate the decision support. This is us. And this is this is our course structures. So we have 3 compulsory units in the first semester in the autumn. So one is business database and business intelligence, which is to describe the data in SQL and also present the data in Tableau. We also teach the student how to develop the dashboard. And the second unit is called optimization spreadsheet modeling. When you have the data available, so we use the analysis tools, so for example, Excel, to generate the optimal solutions for a specific problem. So we help the student to set up the objective functions, the constraints, and then they can easily find the solutions, optimal solutions out of the problem. So the third one we use is business statistics and forecasting. That is my unit. So we teach the student what is the principles and theories behind the statistics and forecasting. And then in the stimulus sections, we give them the real-time data, the time series, to first find out the data pattern. Later on, we have a small case afterwards to find out the data pattern and also use the pattern to predict the futures. We use R in the seminars, and there are some of very useful package. We are not limited to. We sometimes provide the extra tools, for example, Python, Excel extra. When we move to the semester 2 after Christmas, so we have data mining and machine learning. That is Python-oriented unit. Students will learn how to use the supervised machine learning techniques and unsupervised machine learning patterns to find the clusters, find the patterns, to produce the more advanced data analysis. And then another compulsory unit is heuristic and simulation, where students have the opportunity to work as a group. So instead of individual project, they work together for a specific problem to use heuristic method to find out the close optimization solutions. And also they have the different simulation software to generate the insight for the business. The analysis in practice unit is the combination of all the skills I mentioned above. So we have the lectures from the industry who give them the real problem. And then we also introduce them how to, for given problem, how to use your skills from the past knowledge to generate the full report for the for a business. So in the real world, we cannot only use one specific skills. For example, we cannot only use forecasting, we cannot only use simulation. We need to combine all the skills together to give the overall a big picture of this problem and find the best scenario for the problem. The student can choose one of the option units based on their interest. So they can, if they are interested on the project management, they can work as a group in the project management option unit. They choose one out of them, these 4. Project management, operation strategies. If they are good at the coding skills, they want to do more on top of their compulsory unit, they can also do advanced business forecasting and or advanced business data visualization. So it is extra component on top of our compulsory unit, give the student more flexible options in the semester 2. So once they finish all the taught unit in semester 1, semester 2, that is almost the end of this month. So in May, they finish all the taught units, and then move to June, they will start their one big project. We call it dissertations. Our students have 2 options in their dissertations. They can work on their individual project, means that they have the data from their own search. So they define the problem based on their interest, find the suitable data site, and develop the methodology for that problem. That is called academic individual project. We also work with companies. So the company come to us around December, early on, and then finalize the proposals before Easter. And then we present the task to the student after Easter holidays. So the student have just a few weeks ago, the student have the understanding, okay, this is a project from the company, and this is their requirement. The company will offer the data side, and the student can decide whether or not they want to work together with them. That is also a part of the interview process. So some of students may have the same interest, so they will do the interviews afterwards. So if they work with the industry project, they will also have the support from the internally. So we have both academic supervisor as well as industry supervisors for the industry project. In the end, we will submit the report on the first Monday in September. So that will be the final submissions for their dissertation unit. So this is the course structure. So you are not alone. When you move to BUS, you are supported by a lot of family members here. So you can see you are the center of this support team. We have myself as the direct study. I'm the primary contact for your academic advice. For example, if you're not sure how to make the decisions on your option unit selection, how you choose your topics for your dissertations, and then if you have any difficulties in terms of the learnings and starting like codings, and then yeah, that is all my daily things. And also I'm with a lot of lovely colleagues in the same schools. We have student experience officer. I always said it's a boss mom for them. When you study abroad, that will be very exciting as well as challenging. So we have the person who will help you from the beginning to the end. So let's say if you have any accommodation issues, you have any some of the part-time issues, so you can always contact us. So medicals, anything you want to ask for help, we have the person who can stop, who can help you. Sorry. We also have program officer, so which is the person who maybe reach out to you before you start this program. They'll sign you in, give you the offer, check all the requirement, and when you move in, that person will give you the access to all the platform that you will use for your learnings. And always when you submit your coursework, that person will help you to set up the submission points for that. We have wonderful career team as well. So it's study is part of your journeys. Definitely we want to support our students for their job applications. So we will have the career support from the beginning of this program. At the beginning of the program, you will be given a lot of trainings, opportunities as well to participate in the real world project. So they will give you the big pictures, how to prepare yourself. Like for example, the CV preparations, the interview preparations, and then when you search for the job, they also give you advice. That is very, very valuable contact point. Students can contact our career advisor even they graduate 3 years after they finish this program. So sometimes our student alumni came back to us and said, oh, I'm working on this role, I'm thinking of promotion. So can you give me the advice on that? So it's part of their journey as well, even you already graduated. So we will give you the advice from our perspectives, and then we will help you to get promoted or if you want to change jobs. So that is a wonderful team here. You are not alone. And also we have lovely students here. You will find a lot of opportunity in BUS. BUS is a lovely space as well, quite peaceful and also close to London as well. So as I mentioned, we have the career team. We help us to find the industry projects for the summer topics. So we will start from the autumn, almost finish. Once we finish the half of the semester 1 units, we will search for the proposals for the coming summer. We will ask our industry collaborators to see if they have suitable topics, and we will sit down together to see that topic is suitable or not. And then once we finalize the proposals and the topics, we will present all the topics to our students before they make the decision. So the company will come to us, give the half-an-hour presentations on the same day, and students will have the time to think about the topic, whether they have interest or not, whether this is suitable, whether it is aligned with their career development, and then they submit their applications. This is one of our projects back to 3 years. So this is one of our closed companies who proposed the topic. They have the train journal search data, and then they want our student to focus on the travel patterns based on the search data. So let's move to the project. This company is called Mistra, and then that is one of the close collaborators for our local train providers. One is GWR, Great Western Railways, and one is the Southwestern Railways. So they have the data internally. once the customer make the web search, for example, if you want to travel from Bath to London, I will tap Bath bar and then London, one of the consuls in London. So I search this ticket and then find the timetable, then price accordingly. I can say, oh, maybe that price is very, very good, and that time maybe so early, and then the customer will make decisions. They click the tickets information, then they may purchase or they end up with the searching at that point. But that generates the record. So we call it web search data. We have so many type of web search data. This is the example for the journey search. For example, when you book the hotel platform also have your search data. Your flight search, when you want to fly from one place to another place, they also have the web search data. So the web search data is very, very common in the current business market. So this type of data is generated by the customers. It is massive and accessible. And it can reflect the customer intention, their purchase intention. So we can use this data to do some prediction. And then from the operation side, we can use this pattern to help us to design the operation strategies accordingly. So we can, the company can use this data to build a quick response system and flexible business strategies. That's why they came to us say, oh, we have the web search data. Can you help us to identify the patterns and also predict the customer behavior? So this is the starting point, and they come up the proposals. We have a student work with them during the summer. So now I let you know how we do this problem in the end. What do we have before we do the modeling? So they give us over 4 million search record from 2020 May to 2021 July. So you can see just over 1 year, 14 months data, it generates 4 million search records. So if you recall, that is exactly the COVID period. So I show the COVID timeline here. We can see the impact from the policy as well later. So we have from the May 10th, we have, before that, we have in March, we have the first lockdown. And then in May, the lockdown had been lifted. So people cannot work out, but they can just go out of the space to have their socials with maximum requirement. And then the situation goes worse, and then we have a second lockdown, and then we lift it in the end. It all happened in the same year. So we have the search record not only reflect the normal pattern, but also from the impact of the government policies. And then what do we have? We have the data side. So we have the data structure accordingly. We have the search count for sure. Search count means that how many of searches we have on a daily basis or hourly basis. Each of the record have their own search timestamps. So when you click the search on the website, we have your search steps that records your search time. And then we have the domains, that is your website that you used for the search record. So for example, you use the different companies, or if you use other search platform companies. So for each search, we have one ID. So that reflects to that specific search ID. So that ID, let's say I search the ticket for one adult without children. So you have one number of adults, 0 children. And then I use the real card. Real card is one specific promotion tickets in the UK. So for example, if I travel a lot as a young person from 20 to 25, you will be given a discount if you have that real card. So if I use that real card, your price will be adjusted. So if they use, and then we say, okay, yes, that is young person card. So we record that information as well. But if you didn't select it, that information will not be recorded for sure. Departure travel pattern. So that is your travel related variables. We have departure station. For example, I want to depart from Bath, and then my departure station will be Bath. My departure date, maybe tomorrow, that will be the next day travel time. And the arrival station, our close to London station will be London Paddington, so I will record the arrival station accordingly. Return date, if you select the return date in your search, so that will be your return date. You can also leave it open. So whatever you put when you search, that will be recorded. So then we have that data from the company side. For sure, we don't have the customer name and then personal information. It's just your search data. So that is very, very useful here. So we aggregate the data at the different time granulates because that you can search anytime you want, any second. But when we do the modeling, we cannot use that data that will be significant a lot to the analysis. So we aggregate them. Let's say we aggregate 5 minutes as a pattern, and then we see the result. We have a lot of challenge when we have this project, and we summarize the 2 most important things. So in terms of literature review, most of the transportation studies, they haven't used the web search data very commonly in their predictions. So they have their history travel data, for example, how many passengers travel from Bath to London, they have their real travel, but they haven't used their web search data in the past. Lockdown is very special here at that time, so we cannot have the history travel data. What we have, the most useful is web search data. How can we use the web search data to generate the forecasting? We did the literature reviews, so we can see how the other field, for example, hotels, flight, they use the web search data, and then we learn from them. And also we need to select the best algorithm to do your forecasting, because different business, they have different characters, and which one is most suitable. So the pattern comes from the time series, the record. So once we have the record, when we record the time as well, so we have the timestamp, we have the record, then we call it time series. So based on the time series, the pattern of the time series, we can try to find out the best solution algorithms. So we have 2 common the very common typical forecasting method is the traditional forecasting method in ARIMA and ETS. And also we compare some of advanced forecasting techniques. We can see profit is also very suitable because our travel data is a seasonal basis. People prefer to travel more during the holiday period, and then they may just travel less during the term times or during their working times. So profit is also suitable for the hourly time series because we want to aggregate the data, and then we also aggregate on the daily basis. So we choose profit as our advanced forecasting techniques here as the benchmark. And then we also want to use the machine learning techniques. As you already know, it is very powerful. So we use the deep AR, which is the algorithm from AWS, is the Amazon generated algorithms. The data I'll give you the Amazon platform as well. So we choose from the literature review as well as the recent studies. We find out the 4 type of method we want to use. That is our benchmarks, our case selected algorithms for our project. So what did we do once we have the data? First, before the forecasting, we want to see the pattern, right? As I mentioned, your forecasting need to be made based on your data pattern currently. So first, we do the data visualization. That is part of descriptive analysis. Once we have the pattern, we do the modeling. Once we find out the data structure, we find out the data pattern, we found the suitable techniques, and then we do the forecasting. Based on the descriptive analysis result and forecasting result, we can generate recommendations. In the end, for the company, what we use as the technical tools, we have AWS is the Amazon platform. We can use it for the data presentations. We also use Amazon forecasting tools. That is very, very useful point because when we did this project, this Amazon forecasting tool has not been officially launched. So we reach out to, we know they have prepared it. We reach out to them, say, oh, we have this company data set, which is very useful for you as well to validate your functions and your tools. Can we get the trial functions so we can help give you the feedback? They're happy to work together with our company, so they give us the trial functions to our student. Now our student try their function and then give their feedback. So at the end of this project, the Amazon forecasting tool launch, they also get the feedback from us. It's a win-win situation. And in terms of forecasting, we use R, as we learned in the business statistics and forecasting unit. When we separate the data, we use Amazon SageMakers. So it's multiple tools, but for the same project. From the distributive analysis, that is the first task, we have, as I mentioned, we have quite long period of the time. We aggregate them together. We show them in the time series. So you can see from the timeline, we covered from 2020 to 2022, but some of the data is predicted data. So we focus on the COVID period. So we list in red line, they say the search count. So the search days, and then we can see that this is the most meeting place open. People can go out. You can see the search count increases immediately, almost 125% increase. And then the departure days you can see also increase. And then when it comes to the second national lockdown, the count decreases here. And then when people stay at home, almost zero count. They still do some of the search. And then when the second lockdown lifted, the search increased a lot, about 50%. And then you can see also impacted by the special event like European Cup. And also when we totally lifted the lockdown, the increases here is also a lot of increasement here. We can see the search count can reflect the impact from the policies. So when the policy opens, the search count increases. When the policy has been limited, the search count decreases. So that is quite useful. We know that data can be used for the prediction because people do search for their travel. They do have the travel intentions. And then we look at into the details, so first of the advanced booking. So normally we want to know, okay, how many days early they make their booking. So instead of the real booking, we have the search count. We can see most of people that time, they make their decisions for the same day. I want to travel this afternoon, and then I search it afterwards. And then if I travel, and the second one will be the day after. So they do the advanced search almost the same day or one day before. For a long period of the booking, let's say if I have some travel plans, I can see for the long day, for the long term, not very long, but short-term travel plans, I may search the 7 days search count here. You can see 7 days, almost a week after, so they will search more than the other days. But for special event, for example, Christmas is one of the special events in the UK. People want to travel during that period. For that special days, people do search it quite early than before, almost 1 month. We can see it's the end of November already. They search their travels for their Christmas plans and also summer. So we do the plans early. People travel a lot during the summer and during the Christmas. And then for that type of trip, they do it 1 month or 2 months early. So now the company can think, we do the recommendation to the company, say, when you design the pricing strategies, for example, your price for the next days, you can say, okay, maybe it is also the common sense. If we do it very last minute, maybe the price is not that good. So the price may increase a little bit because a lot of people do that. And if you travel, you book the travel ahead of the time, you may have very affordable price. And if you want to travel longer, so the company will design some of promotion strategies. For example, now I think it's a little bit late if I want to travel outside of the summer, but it's still a good time. So I can see just 2 weeks before, I can see a lot of promotions for the summer vacations. So they can design the promotion strategies according to the search. So that is the evidence for the company to design the pricing strategies. The second disruptive analysis I want to show here is the stay days. So how long they will spend outside of the, let's say, if I use bus as my example, how long they want to stay in bus. So I can see, okay, averagely they spend quite short time, but 2.5 days. But for the special time, for example, Spring Bank, Christmas, they will stay out more than 5 days. So that could be the search days from your departure until return to the same place. So they can design the promotions. I can give you a promotion, see if you travel 1 week, and then when you come back on the same day, maybe you will have a higher price. And then that will be some of the analysis for different companies. So we analyze the 2 companies here as examples. Some of the companies, they have the same day return. So they may consider the promotions for the same day. And for the companies, the West Coast, they have the longer period of station. So they, according to their departure date and departure station, and then the arrival date and arrival stations, they can design different promotion strategies accordingly, as well as their operation strategies. Though if they design the timetables, they should consider, okay, for this company, they should think about the timetables for the return as well, because people prefer to leave on the day before and then stay for a couple of days and come back. So they should design their timetables accordingly to meet the customer demand. This is the departure days and search time descriptive analysis. I just give you the examples. When we plan the travel, so we can find out, okay, most of the people, they prefer, for example, you can see the blue bar here, blue bar here, blue bar here. Most of the time, they make their search on the Friday. So they do the search on Friday, Saturday, and then they compare to the other weekend, Saturday, they may not make the decision. They have a less search on that day. So when we design the promotion strategies, we can think about, okay, maybe you can do more on Friday and Saturday because people search more on that day. They do their plans during that days, where during the weekdays, they search less than the weekends. So Friday, Saturday are the 2 important days. And of course, people search during the daytime compared to the nighttime. People are sleeping around this time, so they do most of the search during the daytime. That reflects the normal sense, right? So we have the daily daytime departure search, and also we have aggregated search time here. So we also do the analysis for each of the companies. We find out the most popular stations for their business. That is a reflection for them as well. They need to make sure the timetable and also the supply can meet their customer demand. I put a figure here is part of the ticket type. So when you do the search, we can see most of the common search is just for 1 adult only. Among the people with children, so we can see 1 and 1 maybe is too tiny here, but I can see the highest bar is from 1 to 1, which means 1 adult and one child. So when we design the ticket type, as I just mentioned, if you remember, when you give the people the special discounts when they travel with kids, we can think about, okay, 1 adult and 1 kid could be your target customer group if you want to make the promotions. So that is the highest frequency booking search. That is the descriptive analysis. Based on descriptive analysis, I will do a lot of descriptive analysis. I only give you the examples. We also do the number of travelers. We also do the publicity's travel time with business or not business and the real car demand. We do each of the descriptive analysis. We give them the recommendations. For example, the daily search count for that special analysis, we give them the recommendation. If there is an upward trend, we should provide more trains in the future to meet their demand. And also for the pricing strategies with advanced booking days, we can increase a little bit of the ticket price on the day before departure and the day before, on the day of the departure and on the day before their departure. So people still prefer to travel, and then they can just pay a little bit higher than the advance booking. So once the increase replicated, we can think about the holiday season, and then we can think about promotion strategies. And then you can move to your marketing team, say, oh, this is the best operation period you can think about, and then we can link back to the search data to support their decisions. So this is the recommendations based on descriptive analysis. And then we see the pattern. So we can see historical data search could be used for the future predictions, and also allows us to predict the operations much faster. However, we still have the limitations here. The search data could not fully represent potential interest of the customer because we only know that they do the search. They may not purchase in the end, or they prefer to change another travel mode. We are not sure. We just have their intention. We don't have their actual decisions in the end. But we can use the history travel count to support it. That is not part of this project, but we did the recommendation to the company, say, okay, this is a prediction based on the web search data. Definitely the same company, they should have their real travel record, and then you can compare, and then you can validate how far away of your forecasting from this project compared to real-time data. And we can use visualizations to show the pattern, but that could be easily biased because we cannot compare the real data. And once you have the real data, definitely that will be your comparisons. We don't have quantitative studies based on the correlations because we don't have so much of the evidence that time. We are data analysts, so we don't have that data. That's why we couldn't do the correlations. Whether the correlation is significant of your weather's impact of the search data, whether a policy is significant, we don't have that statistics to support our analysis, but we have the trend here. And we only have the data from the policy cities and stations. We don't do the rest of the stations and cities because we only have 3 months for the project. So we only select the public cities and stations for the prediction analysis. That is our limitations. We mentioned this clear to the companies. They can use this kind of recommendation for their further study. And then we move to the modeling part, the forecasting modeling. So as I mentioned, we use the Amazon forecasting tool. So we first do the time series selection. So we have so many time series. So we select the popular cities. So we have the popular stations, and then we compare the forecasting algorithm. In our unit, we do all the forecasting in R, but here we use the Amazon forecasting. It's much easier and user-friendly tools. Students just select their time series and then select their preferred algorithm. So Amazon forecasting can do all the coding in the backside, and once the result is generated, our students do the result interpretations. Maybe we compare the different, we have several selecting methods. So we want to select the most suitable one. So we do the evaluations based on our actual measurement, and then we conduct the forecasting experiment, summarize our discussions in the end. So, and then we do the recommendations to the company. That is a flow. I will try to cover less technical part. I give you the overview of the time series forecasting, how we do this. So we have the time series data. We have hourly time series data. We have daily time series. Hourly means that we aggregate the time in 1 hour. So this hour, we have the search from here to that point, how many times. And that is the hourly time data. We can also aggregate the data on a daily basis, means that we have the total, in total this day, we have how many search from here to that point. So that is a daily data. So we have different time series and type. We should use the algorithm that is suitable for both type of the data. We use 2 common, very, very classical methods for the forecasting. They can be used for both type of the data. We use ETS and ARIMA. So those are the 2 classical time of the algorithm we used, and then we also compare with Profist, is the advanced forecasting method, as well as machine learning type of the forecasting method. So we use these four. We compare, okay, if that is suitable for small, medium time series size, and if we can use this for holiday or special event forecasting. So this is our justification. Instead of using tons of the forecasting method, we select the best suitable method. And then we use part of the data they give to us. So we have the entire data set. In the forecasting, we use part of the data set and half of the data set as a training set. Training set means that I give this data set to the method, and then the method learn from the history data. And then they develop the best of models. We use about one quarter of the data for testing to see if our developed method can be used for comparisons. And then once we select this method, we use it for the evaluation. We have another small samples for the evaluation. After evaluation, we can find out the best of some forecasting method. We compare the error terms. Error terms here we select is RMSE and MAPE. So that is also type of the selection process. We have so many error management indicators. The student choose these two because they are suitable. The student documented it here, so why they choose these two. But the less, the better. So if we have less errors, means that this method is suitable, as the performance is better. So for the time series forecasting, when compare the KPI, the key performance indicator analysis, we compare the input data length because we have so many time series. Whether we put it 1 month, whether we put it 3 months, or we put it the whole year. So that is the input data length. We compare whether the short-term theories can predict the forecasting well, more accurate, or we give them more data, the prediction result is more satisfactory. Or the forecasting horizon analysis. It means that for long term, for example, I just predict the usage, the demand for the coming days or the coming 7 days or coming 1 month. That is our forecasting horizon analysis. Whether we do the weekly forecasting or I do the bi-weekly forecasting or I do monthly forecasting. So should I use automatic machine learning or I just use classical method to do the forecasting? I also want to know, okay, we always know that machine learning is very powerful. Should I still keep using the machine learning or I use the traditional way to do the forecasting? Or should I do the aggregate analysis? Should I do the normal analysis? So we do the comparisons in our analysis, and then we come up with the result. So we can see those two, just repeat again, those two are our selected error term. So the small, the better. So if they have a small error term, means that the performance is better. We can see a highlight in right. We can see this is the traditional forecasting method. We give them 6 months data. The error is the smallest. So I can see, oh, this is a recommended forecasting strategy. You give the model 6 months of data point, and then it will generate the smallest error terms. That is the recommendation from this part. Forecasting horizon analysis, I say, oh, if I want to forecast 1 to 3 days, the error is the minimum. So that is also aligned to our common sense. If we have the forecasting for a short-term period, the error term is the smallest. And we can also see the smallest error term come from deep AR, not the ARIMA and ETS method. So machine learning is very powerful for a short-term period where when we move to a longer 1 to 12 days forecasting. 12 days forecasting, so the error term here is 0.7 and ARIMA is not that bad, ETS 0.11. So the error is not that significant different to each other. So we recommend ETS is recommended to produce reliable prediction, and the DPAR may have better performance when we're forecasting the longer term. So automatic machine learning could find the models with the best accuracy metrics to produce a forecast. So we compare the different methods. So we can see automatic machine learning method is the winner here in terms of all the time cost. And then we can also see the performance out of the evaluation is the best. When we do the time gradient analysis, so we could use daily data that is from our result to optimize the overall planning. But the performance on the prediction search volume of each arrival cannot be guaranteed because that is you can see the error term here, they are quite separate to each other. When you aggregate, we can predict the overall planning. That is our recommendation. But if you want to target for each specific stations, we should do it separately. If you remember from my previous presentation, for each station, their travel pattern is different. That's why if we want to have a prediction for specific station prediction, we should do it separately, not from the overall aggregation. Based on the forecasting result, we have the suggested recommendation as well. For hourly data, we suggest them to directly use DPAR as the amount of hourly data is usually very large. So DPAR is very useful on that point. For daily data, we can use auto machine learning first to determine whether the winner is the traditional algorithm. If yes, we can use the traditional algorithms rather than the advanced machine learning method. So when we forecasting a single time series, we recommend them to use traditional algorithms. For example, we just use ETS to explore the forecasting abilities, and then we predict the multiple time series of different time series together. We can use automatic machine learning or DPAR. We do have the limitations here because the impact of the holidays and events on time series is still unknown. Maybe for the company, when they have the data, they can do what if analysis. They can have the data, what if this is a holiday? And then they do analysis for that day. And then if that is the special event, they have analysis that day. They do the comparison for the based on the what if analysis. Our mainly prediction search record is before lockdown, and then we don't have that data at that time for the student project. So when they have the more time of the data after lockdown, they can split the data into more subset. So for example, the training data they can cover more time series after lockdown, and then the prediction could be more useful for them for the same of the lockdown period and after the lockdown period. And we also found that, okay, DPAR did not reach its full potential because that time we use Amazon forecasting tool that is not officially launched. So we only use their travel version that time. I'm sure that they have better performance at this moment. To summarize my presentation today, we can see business analytics offer strong global career opportunities across many industries. Here I use the transportation industry as an example. We have students work in the bank, in the consultant company, in the healthcare sectors, in the supply chain sectors. So we can work with many industry sectors. And our hands-on practice experiences helps the student to develop the skills. So the one we use, the traditional method, the ARIMA and ETS are learned from our business statistics and forecasting method, and auto machine learning is from our machine learning units, and the student use the DPAR, which is from applied in practice unit. So those skills help the student to develop the whole stories for this project, and then that will be the single project for the company. And then the combination of business understanding and coding skills can create meaningful business impact. We not only provide the coding to the company, we also provide the business insight out of the result. So we give them recommendations how they best allocate the resources, how they best decide the pricing strategies. That are our recommendations in the end. Thank you so much. That's all my presentations. I'm happy to take any questions from your side.
Uh, Thank you so much, Dr. Monk, for such an insightful and comprehensive session, I would say. Thank you so much.
Thank
So,
you.
guys, time for the Q&A session. Uh, First question is from Lakshmi Singh. Why is descriptive analysis useful in data science?
Why is descriptive analysis useful?
Descriptive
That
analysis
yeah.
useful in
Yeah,
data science.
very good questions. So we start our descriptive analysis in our semester one because we have the data. Once you have the data, we want to do something for them, right? If you're not clear what the pattern of this data, we cannot select the best method for the forecasting, for the optimizations, for the clustering. All the analysis is based on your current pattern. It means that, okay, I want to know something, but first of all, I want to know the existing status of this data, the pattern, the trend, whether they have increased trend or the download trend, or whether they have seasonal patterns or they have monthly patterns. Once they know the data in details, and then they can find a better algorithm for the further analysis. That is why descriptive is very, very useful and powerful at this time. I can see the change from the past years because we work with the companies, they come up the proposals to us. So I can see at the beginning of my DOS period, I think only one or two companies came to us and said, okay, I want to show the data in a visualization way. So you create the dashboard for me. So only very small number of projects that time. Because they don't have so many of the data, they can do manually prediction. They can do manual analysis. They don't mind if they miss one of the data. They don't mind if they just skip some of the data. But now they have so many data. They cannot do it manually anymore. This year, about half of the project from the company, they ask our student, can you help us to develop the dashboard? They want to see the data pattern. They want to say, oh, do I have this business in that area? Do I have that limitation in that area? They know they have the data, but they don't have the ability to develop that one in first. That is all from your descriptive analysis. We explore the data on the current status, and then our student help them to show the data in the dashboard, and then they find the pattern. And our student will also have them to do the recommendations. They can also do statistics and will do optimizations in the end. That is a foundation for the business analysis.
Thank you. The next question is, which variable increase more rapidly in the graph? I think it's related to the descriptive analysis, the charts
Yes.
you have shown. Yeah.
The search count. We use search count more often. That is our target because we want to know which day they search more and how long they use that they search it more. So search count is the foundation for this project particularly. They want to know if they have a higher demand. So I should first of all supply more train. So they should cover the demand in full, and also they can think about the price higher to get more profits.
Thank you. The next two questions is from Nancy Mathur. Hello, Dr. Mung. I wanted to ask, do students get exposure to internships or any industry projects during the course?
Oh, that is very, very good question. So that is our plan. So currently we call it industry project in the dissertation. In terms of name, they are all included. They both included in the dissertation unit in the semester three. And then our students said, oh, we prefer to call the industry project internship because they will advance their CV preparations. We already submit this proposal to the university. We know that we did it in the summer dissertation, but they want to see the name in terms of the course structure. Maybe next year when we have the presentation, I will call them. In the summer, we have dissertation and we also have internship. So we do have the opportunity for the student. So across the first semester and second semester, we invite the industry partner coming to the university to give us the lecture talk. And also our career team, they have the activity called Future Leadership Challenge, which means that they give the student a specific project. It's not mandatory, it is optional. So if the student have the interest, they can do the challenge. And once they complete that challenge for that company, they will get the certificate. In the summer, if your student work with the company, that could be the very good experience because they will get in touch with the student over 3 months period. They know what the real business look like. So that is the real project for the student before they jump into the job market.
Next question is, what skills should we develop for being a good analyst and to differentiate from a great decision-making strategist in the real organization?
Oh, yeah. I would say no, with AI, the thing changed a lot. Before that, we asked the student we should have very strong, solid programming languages as well as a solid business insight knowledge. So based on the numbers, we give them the recommendation. That is for sure from business school, but we also give the student coding skills that time. And now I think now our course also reflect that changes from the AI. So we teach the student the coding skill at the same time, but also we teach the student how to use the AI at their best levels. So we can use AI to train our model for sure. It's not limited in our program. We teach the student how to use the AI, how to use that power to generate the insights, generate the coding, but our student is the key to decide it. It's not all automatically from your ChatGPT. Is your training process is important. How you develop your training code and then how you modify this training to your specific project is our training process.
The next question is from Harshit. How can this analysis help in future forecasting?
Future content. Yes, this company is our very good collaborator. So we have the project from them every year. So that time we compare, they want to know, oh, should I have the forecasting DPR from Amazon because you know that commercial software is always very expensive. We give them the results. Say DPR is useful here, here, here. You can consider it. And then based on their data, because that time they only have the client from the local train company. Based on their data pattern, we recommend them to use the specific forecasting. We give them 4 recommendations. They installed it for their project as well. And I think the year after, they have more clients. They have the other customers, not only in transportation, but also the other factors. So they also consider the other forecasting algorithm. Again, the basic is to see whether your time series is suitable for the specific algorithm. We have the selection justifications before we reach the forecasting method. We don't have one single powerful forecasting algorithm. Students know it. There is no one powerful way to do the everything. We should know the details of the problem first, and then we select the most suitable one for your forecasting project. That's why we call it, you should explore the pattern, and then you find your justification. You need to find the way to decide your decision in the end, and then we help the company to decide the best forecasting method.
Perfect. So that's it. Thank you so much, Dr. Mon, again for the very comprehensive and insightful session. Thank you so much, guys, for joining the
Thank
session.
you
I
so
hope
much.
you find it very useful. So thanks a lot and wishing you the
Thank
very
you so
best for
much.
the day ahead. Thank you so much, Dr. Mon.
Thank you. Good to
Bye.
see
Bye
you.
bye.
Bye, yeah.
Yeah, likewise. Take care. Bye.
Take care. Bye.